Now here's a double replacement reaction. Okay, now see, can you figure this out? Here it comes. Here it comes. Pay attention. Barium nitrate, which is Ba bracket NO3 bracket 2, because barium has a 2 positive charge and nitrate is -1. We'll say that that's a solution of barium nitrate being mixed with a solution of sodium sulfate, which is Na2SO4. SO4 is 2 negative, Na is positive 1. So a question could be, these two chemicals are mixed together, write the reaction and balance it. Well, what are they going to form on the other side? Look, it's double replacement now. The metal, or the cation, is going to go with the other anion. And the cation from here goes with the anion from here. And remember, now I didn't mention this before, but you got to write the cation first and the anion second. Always. It's always positive before negative. Always. So, in this double replacement reaction, the barium chemical here is going to go with the sulfate. But you got to use the proper charges. So what's the charge of Ba? It's 2 positive. You check on your chart. What's the charge of SO4? It's 2 negative. So Ba 2 positive, SO4 2 negative makes, quite simply, BaSO4. Now, what else is produced here? Sodium goes with the nitrate. It's Na positive, NO3 negative, so it's NaNO3. Write Na first because it's the positive ion, so it's NaNO3. But what are the states of matter here? When you look this up on your chart, that Ba2 positive with SO4 2 negative goes under that solid column, which means that if the concentrations are sufficient, this is going to precipitate out as a solid chemical. And maybe in class you're going to be able to mix chemicals together and form precipitates. Well, this is just a way of predicting whether precipitation occurs or not. This is a solid. But nothing precipitates with nitrate, and you know what? Nothing ever precipitates with sodium ions either. I mean, generally in normal concentrations. And so this one would be AQ. That should be there. I'll sneak it there. So, that's the solid, that's AQ. And in my class, if you get this whole thing right and you forget that solid, I marked the whole thing wrong. It's tough, but it's fair, you know. Now look, how do you balance it? 1 to Ba, 1 to Ba. We got the 2 nitrate here. And what do we have there? We have a 1 nitrate. 1. That's okay. Chem guy's half Italian. He's allowed to do that. So, look. 2 nitrates here, 1 nitrate here. Put the 2 in front. But that means now, well, let's go back. 2 sodiums. Hey, but we got 2 sodiums. That's all good. So therefore, look. SO4, there's 1 here and 1 here. We're done our balancing. 1, 1, 1, 2. And that's how you do double replacement. That's not so bad. I'm going to sneak another single replacement reaction in here because this one is a little bit different than the other ones. And boy, it catches my students all the time, so I thought that, you could learn from this too. If you take iodine and react it with a sodium bromide solution, what do you get as products? Okay. And balance the equation, of course. Well, here's the thing. A lot of people are used to just taking this and substituting this, so Na goes off by itself and I goes with the Br. No! Don't do that, because here's the thing. You know, when iodine, which is I2, group 7 on the periodic table, when it bonds to something, it has a negative charge. You go, look, it's a -1 charge on your periodic table. So it doesn't actually go with the bromine, which is also a negative, but the sodium goes with the iodine and the bromine goes off by itself. So in this case, this thing is going to replace the negative ion and then go with the positive. Now actually, it doesn't really bond sodium and iodide either. When we get to the solutions unit, which is on the other disc, you'll be able to see that in solution, a lot of these compounds stay floating around and don't bond to each other at all. Ooh, okay, wait till later. It's coming. But right now, all the rules still apply that we've been doing. I2 with NaBr, so the Na goes with the I, because that's a negative and that's a positive. And by the way, Na is +1, I is -1. Yeah, but if there's 2 there, don't worry about it. When you're bonding things, you use their ionic charges, not these numbers down here. So Na is positive, I is negative, that's NaI. And you'll notice on the solubility chart that Na here doesn't like to precipitate with anything under normal concentration, so it's AQ. plus, well, what goes off by itself? Br. So all you have to do is write down Br, right? You don't just write down Br because it's in group 7. No, group 7, they're all diatomic, it's a 2. And by the way, on the periodic table, bromine's a liquid. And so you put an L. And now that actually looks like a good equation, except for the balancing, but maybe even then. 2 I's here, only 1 I there, gotta put a 2 in front. 2 NAs, there's only 1 in there, gotta put a 2 in front. 2 NAs, 2 NAs. Now we go back for the BRs. 2 BRs, 2 bromines. It's balanced, 1, 2, 2, 1. That's beautiful. That's single replacement, but replacing the negative ion.